So we need to find the antiderivative of this. So before doing this, we are recording here. Okay. In order to find the antiderivative of this, remember that if we have the function f of x plus g of x plus h of x, then antiderivative of these guys will be the antiderivative of f of x plus antiderivative of g of x plus antiderivative of h of x here, right? And the most general derivative, then we add with a constant. So it means that we need to find the antiderivative of this guy, and this guy. So we do step by step, one by one. So antiderivative of 2e to the x is, what is it? Yes.
It would just be the same thing, wouldn't it?
Perfect. Yeah. 2e to the x. Good job. And you can double check it by taking the derivative of the antiderivative here and see if it gives us the correct answer, right? Double check it here. When we take derivative of 2e to the x, it gives us derivative of e to the x prime. The number, we can take it out of the derivative, right? Then e to the x derivative gives us e to the x. Yes, and it confirmed here. So we are good. That is the first guy. So the second guy, antiderivative of the negative sign here, we don't care about that much for now. X to the negative 1. Okay, now is the normal way is the antiderivative. Let us call it g of x. Okay, then as I mentioned in class, we cannot do it this way. Normally, the antiderivative of power function, we add 1 to the power of it, and then divide it by this power at the constant here. However, if we do it this way, this guy does not make sense. It is not defined. So we should be very careful with the function when the power is -1. And if you download the notes on Moodle, you see that this notice there. So, but remember, natural log derivative here, it gives us 1 over x, right? And 1 over x, which is x to the -1. Same things. Therefore, antiderivative of this guy should be 5 and multiply with natural log of x here. Right, the constant is not a problem. So you can double check it by taking the derivative of this guy, and it gives us 5 over x, correct. So, and the third guy here is secant, oh, this is not secant of x squared. This is secant square of x. Sorry about that. So, remember, in order to do that, we need to memorize all the derivative formula. If we remember them well, we can do it fast. So remember that derivative, oh, let me write it in terms of prime. Tangent of this, right? Oh, okay, very good question. But before doing that, let me write derivative of tan gives us secant x squared here, right? And convention, secant of x, the whole thing square. We can write it secant square of x. They are the same thing, but they are different from secant of x squared. In this case, the angle is x squared, but in this case, the angle is x, but then having the value we square. So they're different. But these guys, they are the same. Okay, just notation. Yeah, that is a typo. What I meant was secant of x, then square. My bad, sorry. If we need to compute the antiderivative of secant of x squared, it's really hard, right? Because, yeah, something derivative give us secant is hard. Yeah, this makes the questions a lot harder. So anyway, therefore, antiderivative of, oh, I use, yeah, let us call it here k of x or anything else. Just don't be confused with the names of that. Of 2e to the x plus minus 5x to the negative 1 plus secant of x square, secant square of x here is 2e to the x minus 5 natural log of absolute value of x plus tangent of x. And remember to add a constant. Right, that's it. Most general antiderivative.